Hello, kids. Today we're going to learn about efficiency. We have seen before that energy is transferred from one form to another. For example, electric energy to heat energy. We must understand that they're not always transferred to the form that we want. This is because not all devices are 100% efficient. So in today's video, we're going to closely evaluate efficiency and also see how to calculate it in terms of both energy and power. We are going to take the example of a lamp. A lamp receives its energy, or in other words, its input energy is in the form of electrical energy, while its output is in two forms, heat energy and light energy. Heat energy is regarded as non-useful energy and light energy is regarded as useful energy, since the purpose of a lamp is to provide light. All extra forms of energy other than the main use are classified as waste. And this is what gives us the concept of efficiency. Efficiency is basically just the proportion of energy converted into useful energy output from the total, which in this case is light. In your exam, you're asked to calculate it in two forms, as a decimal or as a percentage. The following equations are used to do so. If you're using energy, the above equation is utilized, and if you're using power, the equation below is used. We're going to put this equation into practice by taking two lamps. This one has an old incandescent bulb. We're going to provide both the lamps with 300 joules of energy, and the bulb on the left will only convert 45 joules of it to light, whilst the other one is an LED bulb, and that bulb converts 225 joules of energy from the 300 to light. Now the question is, how many times more efficient is the LED lamp? For this, we first need to calculate the efficiency of both the lamps separately. For the incandescent bulb, we'll divide 45 joules by 300, and for the LED lamp, we'll divide 225 joules by 300. We have divided the useful energy output by the total energy input. This gives us the efficiency of both the lamps. Now we divide the efficiency of the LED lamp by the efficiency of the incandescent lamp. This gives us an answer of 5, which means that the LED lamp is 5 times more efficient. These figures have been calculated in the decimal. If we wanted to convert them to percentage, we'll just divide each of them by 100. This gives us 75% and 15%. However, dividing them will give us the same result. A common mistake that people do while calculating efficiency is getting the divisions the other way around. However, you can easily point out this mistake since your value will be greater than 1 in decimal or greater than 100% in percentage. So if you get a value exceeding that, your answer is wrong, and you should do it the other way around. Now we'll take an example of a 70% efficient microwave, which has a total power input of 800 watts, and you have to calculate the useful power output. Firstly, you'll take the efficiency equation which uses power. Then you have to rearrange it to get useful power output as the result. Then you'll convert your efficiency into decimal by dividing 70 by 100. This gives you a result of 0.7. Now you will multiply this efficiency by the total power input, which is 800 watts. Hence, your useful power output will be 560 watts. Now, one thing that you must remember is that no device is 100% efficient. All devices produce some form of waste energy, and it's mostly in the form of thermal energy. However, there is one exception to this rule. The devices that's purpose it is to produce heat energy in the first place, for example, electric heaters. Even if they produce large amounts of thermal waste energy, it wouldn't technically be a waste. Instead, it will count as useful output since that is what's required from them in the first place. That is all for today. Goodbye, kids.